Am I audible in the back? Yeah. Okay, so good afternoon. And welcome to this next session of CIIPS. क्या हो गया सर आपको? नहीं, कुछ नहीं हुआ. So, what were we doing in the last class? Flow analysis, and we did a flow analysis of the RPM process, and we looked at different kind of functions when it comes to processes, and we then looked at how to analyze a flow. So what are the kind of functions that we have in a flow analysis? So we had three categories of functions when we talked about function analysis for products. Those were
supporting function.
For products, they were basic function, additional function, and auxiliary function. For processes, we said that there are three kinds of functions again, but now they are of different type. First set of functions is productive functions. So what are productive functions? Yes, productive functions are those functions which result in a irreversible change in the product, and you can see that in the final product also. Those are productive functions. And just like basic functions को हमने highest rank दिया था, we said productive functions are the highest rank because they change the product for good. Then second type of functions are providing functions. What are providing functions and why are they needed? So providing functions are functions which enable the productive function to work well, which enable that the flow moves along well. So there are three kinds of providing functions, which are supportive, transport, and measurement. Supporting functions का हमने example क्या देखा था? If you have to mold an iron, you have to heat it, then you hammer it, and that is not evident when you finally use the product. So that heating was to enable a productive function to happen easily. That is a supporting function. Catalysts that you use in any process, they don't get utilized, they don't get consumed. जैसे थे एंड में भी वैसे के वैसे रह जाते हैं, but everything else changes. So catalysts are carriers of supporting functions. Are you with me? Then the second kind of functions we talked about were transport functions. These are easy to understand. Easy to understand when you talk of a physical system. What could be transport functions, let us say, in your software programs? Even आपके हार्डवेयर में भी what could be transport functions? FIFO or cache. Okay. Buses, you're moving data information from your microcontroller, microprocessor to the memory array or wherever. So buses, clearly the buses are doing the function of transporting. Many times in your software programs, you would have a dummy array or a dummy location where you would scratch place, where you would write something and then move it into a different place, save something in some other location. All those are transport functions. Microcontroller programming mein you do see, one is load. Load is clearly a ट्रांसपोर्ट फंक्शन। लोड में क्या हुआ, कोई इंफॉर्मेशन मेमोरी से पिक हुई और आपके पास प्रोसेसर में लोड हुई। पॉइंटर्स आर again transport functions. They help you navigate, they help you move around in the system so that the job that you wanted to do gets done. Are you with me? Then the third kind of functions, which are called providing functions, which are they? Measurement functions. Why do we need measurement functions? To have the dimensions of the product, to ensure that जो भी आपने loop insert करे हैं for I to X. So for I to X is a loop. Continuously you are measuring the value of I. As soon as I exceeds X, you say now don't enter into the loop. So measurement functions are a part and parcel of every system that we create. Last time we talked about measurement functions also in terms of quality. But quality is one aspect. I realized later कि you might have completely missed the aspect that measurement functions के बिना आप कुछ भी नहीं कर सकते. Unless you measure, for example, आपको any business process also, suppose you have to deliver 25 components. 25 components have to be counted or measured or weighed or something so that then you close the package and ship it. Are you getting it? So measurement functions are a key part of every process again. Measurement function में क्या मेरे, suppose I'm making a shipment of soaps. Have they changed the soap, how the soap looks or feels or touches? Nothing. I just counted 5 soaps, put it in a pack and said this is a pack of 5 soaps. But this movement was, or this measurement of 5 was necessary. Are you getting it? So but they are not productive functions. They are only providing functions. Are you able to see this? So अभी तक हमने productive functions की बात करी, which are at the time of manufacturing the product or something, where the evidence of having gone through that function is visible even in the final outcome. Second, हमने providing functions की बात करी. 3 types of providing functions. First is supportive. They just are like catalysts. They make the system work. Second is transport. Again, very necessary so that you are able to move whatever you need to move around in the system. Third is measurement. See, आप किसी भी चीज की बात करो, जैसे उज्जवल अभी उस पे काम कर रहा है, वीडिंग रोबोट पे काम कर रहा है, ठीक है? तो अगर जो हमने we discussed about that kind of a robot in one of our brainstorm sessions also. So a rover has to go, has to look at a weed. So movement, transport आया, look at a weed, analyze, supporting आया. अगर वो weed है, तो अब उसको हटाएगा. Only that function is productive. Remaining everything is only providing. Are you able to see this? Now, जब वो weed हटाया, वो weed अगर पूरा नहीं हटा, तो अब corrective function डालना पड़ेगा. So the third category of functions is corrective function. That you wanted to accomplish something, it was not accomplished to the desired level of quality. So you have to do some corrective action. This has to again happen everywhere. कोई भी आप काम कर रहे हो, आप एग्जाम भी देते हो तो you revise. That revision is a part of corrective process. Now, if कोई गलती नहीं निकली, revision will be very fast. But अगर गलती निकली, तो you know that okay, you recovered something. In the morning in the memory class, you were talking about repair. So those of you who were there, repair is a corrective process. Are you able to see this? So what I mean to say is that आप see, just like we did products के लिए function modeling, आप कोई भी process pick कर लो, you will be able to identify this is one of these functions. Are you able to see this? Now, once we have mapped the entire flow into these functions, their cost, and everything, we can also start to identify what to trim. Which ones do you want to trim? Least functionality. Least functionality के लिए हमने क्या कहा था? Corrective have the minimum weight. Providing have a higher weight, and productive have the highest weight. So least functionality, you will see corrective functions will always be the first ones that you want to trim. Okay. Then एक तो weight की बात आई. Then other things would be cost of every function. Measurement के अंदर, and different things cost could be considered differently. For example, when you are writing a program, cost could be in terms of number of cycles it takes for that particular function to happen. Cost could be in terms of what is the memory footprint it takes. The cost can be estimated differently for every use case that you're talking about. In a portable device, cost can be in terms of how much battery it consumes. So whatever is your MPV for that particular product, for that particular process, that will result in some cost estimate. So whatever has higher cost but low functionality, that you want to trim. Again, very similar to what we did for trimming in products. Are you able to see this? Clear है? यहीं पे जैसे हमने प्रोडक्ट्स के लिए लेबलिंग करी थी, sufficient action, मतलब normal action, excessive action and insufficient action. That same labeling can be done here also for every function. So that is not new. वो आपको already आता है. Are you with me? Then we enter into the part of trimming of flows. And in trimming, the first thing we said was we would want to trim the corrective functions. Second, because many times you will realize that measurement, because it involves comparisons, measurement is the next function you would want to trim. Then you look at other functions that you may want to trim. Whenever you trim a function, what are the key rules that you have to follow? When can you trim a corrective function? When the
It's when there is least.
आपको अब करेक्टिव फंक्शन मैंने कहा आपको ट्रिम करना है, आपने आइडेंटिफाई कर लिया, आई वांट टू ट्रिम दिस फंक्शन. What does trimming mean? Trimming means that this function, the work should be done, but this function should not be required. The separate step should not be required, but work should still be done. It means something else need to be assigned that activity. So we saw that for every function, we first would want to see, is this function even necessary? If that particular activity, क्योंकि आपने अपना process change कर दिया, that activity is no longer needed. Obviously, activity is no longer needed, function can be trimmed. और आपने जो process change करा, उसकी वजह से the impact of that activity is already under control. Remember we talked about defects की intensity कम कर देना. Defects की intensity अगर आपने कम कर दी अपने process के through, no correction is required. Are you able to see this? Then we said that अगर फिर भी आपको कुछ करना है, तो try to do that corrective function in a function which is either preceding or following. यहाँ पे ध्यान रखो, this is very different from what we did in products trimming. In products trimming, we said you can assign the function to another component which does the same function somewhere else. You can assign the function to another component which at least has an interaction with the object. That was what we were looking at. यहाँ पे, in flows, the function is reassigned to either the previous function or the subsequent function. Not far away. Because, for example, corrective function. Can you do corrective function अगर वो defect अभी तक introduce होने की stage ही नहीं आई तो? See, a defect is introduced जैसे RBM process में the defect was introduced when we were cooling. तो अगर cooling हुई नहीं और कहो मैं corrective function करने वाला हूं, does it make sense? So in flows, you cannot simply reassign the flows just because हाँ हो रहा है वहां पे कुछ. In flows, identification of where to move this flow, where to move this function when I'm doing that particular activity, it has to be done very carefully to either the preceding or the following function. Now that function can be productive, transport, measurement, whatever. But whatever you trim, that is what you do. That is the only flexibility you have, either preceding or following. Now if your flow actually, for example, आपने एक flow chart बनाया जहां पे एक particular function पे आप 4 रास्तों से आ सकते थे. Can happen. You may have an algorithm or a flowchart in your process where you could arrive at a corrective function from 4 different places. Now, where will you move this corrective function now?
Longest way.
You will have to evaluate each of those 4 pathways. In such a scenario, if after the corrective function there was only one pathway, then instead of replicating or transferring this function to the previous 4 stages or previous 4 paths, you would rather choose to transfer it to one path at the output. Are you able to see this? So there are different set of restrictions when it comes to trimming in flows. Or you may feel that, okay, इसको ऊपर वाले 4 में transfer करना is easier than नीचे वाले 1 में transfer करना. That is also a choice you may want to make. But that is always very contextual. You can only move functions one step up or one step down. Now, once you have moved, you have a new trimming model and then you can trim again. So finally, your activity or function may have moved 10 steps up. Are you able to see this? But at one point of time, you can only trim one step up or one step down. Are you with me? Does this make sense until now? Any questions? See, आपने एक चीज notice करी है that trimming has a clear hierarchy of rules. Only when you follow that hierarchy of rules will you be able to do most efficient trimming. Again, I reiterate that trimming is also just a problem identification tool. Here also, trimming is not a solution finding tool. Trimming is only a tool to identify problems which are easier to solve, so that you do not waste your time and energy in complex problems which will lead to the same outcome anyways. But they are more complex, so more time resources would be utilized. So trimming is an exercise to simplify your work. So have I shared this with you? Professor Vishweshwaran is my PhD guide. He used to say that a good engineer is a lazy engineer. So as a good engineer, always find the cheapest problem that you would solve. Automatically, you will come up with a smart, elegant solution. Now, lazy did not mean that काम नहीं होगा और काम रह जाएगा. काम तो होना ही होना है. But they found the smartest way to do it. And trimming takes you there. Are you with me? Any questions? तो अभी आपके एक प्रोसेस को ट्रिम करें. Should we look into one small process and trim that also? RBM we did. RBM we did not really do the trimming part. We actually did the correction part only. But let us look at trimming also as a part of a process. So, how many of you eat cake? ओके, सब लोग केक खाते हैं, तुम नहीं खाते हो? खाते हो? Okay. सब लोग केक खाते हैं. How many of you have baked a cake? पेटू खाना है, बनाना भी आना चाहिए. So those of you who have baked cakes, those of you who haven't, who have just eaten cakes, do you notice that at times cake थोड़ा सा टूट जाता है सरफेस पे, कुछ कुछ ऊंच नीच हो जाती है? So if you offer that kind of a cake to a visitor, a guest at home, does it look good? No, cake should look perfect. Celebration hai. There's some celebration, that is why you baked the cake. And now this cake is not looking good. So should we do the flow analysis for the cake? Why does that happen? So all of chefs, all the great chefs over here who have made cakes, now you can flaunt your knowledge of baking. Huh? तुम तीनों को चुप रहना पड़ेगा. इसमें इतने हंसने की क्या बात है आदित्य? बताओ बताओ. Okay, so yummy cakes there. The challenge is that to bake a cake, those of you who have baked cakes, it takes a long time. 30 minutes, 45 minutes, depending on what kind of an oven you have, but it takes a long time to bake cakes. And so you want to increase the productivity. That is one aspect of it. Another aspect of it is that kuch na kuch deformations, there is so productivity of the cake making is a slow process. But wastage is also very high because some deformity, something happens. And then you can't give it to a user, can't give it to sell it in the market. There's a lot of wastage. You somehow want to remove all of that. Now cakes, just don't think of those cream cakes. Let us say even जो Britannia cakes आते हैं, anything. So आप market में भी अगर sell करना चाहते हो, तो you can't sell such a cake. So something needs to be done. What are the disadvantages of the present flow? First, the productivity is very less, and then defects start to appear. The cake starts to break from the top. एक level तक का breakage है तो वो चलता है. उससे बड़ा breakage हुआ तो you can't sell that cake in the market. So something needs to be done about the entire process so that both these things are taken care of. So our goal of the project is to increase the productivity and to eliminate the defects. So do you realize that when I'm saying eliminate the defects, I'm already talking about some corrective action or some changes in the process ताकि corrective action भी eliminate हो जाए. Productivity enhance का मतलब I'm somehow also talking about some supporting functions, some measurement or timing, other transport, all those functions will also come into picture. Process है तो process में हर तरह के functions हैं and everything will come into picture. So before we go into which functions are there, we first list down what are the operations. So what are the operations in a cake making process? So you first prepare the batter. अब experts बताएंगे क्या क्या डालते हो आप बैटर में. Refined flour, then मेरे को एगलेस चाहिए, बट एग्स भी डाल देते हैं. एग्स, शुगर, एसेंस, ऑयल, बेकिंग सोडा. ठीक है, ये चॉकलेट इसको पसंद है, तो चॉकलेट फ्लेवर. सो वी प्रिपेयर अ बैटर. दैट इज द फर्स्ट ऑपरेशन. उसमें हम क्या क्या करेंगे फंक्शंस पे भी आते हैं, बट वी टॉकिंग अबाउट. सोनिया को भूख लग रही है. अब ये 15 मिनट तो खाने की बात करनी पड़ेगी सोनिया. Then we fill the mold. हमारे पास केक का एक मोल्ड है, हम उसको फिल करते हैं. And then we put it in the oven. We bake. है ना, तो ट्रांसपोर्ट का एक प्रोसेस था. यहाँ पे कन्वेयर बेल्ट लिखा है because we're talking about an industrial process. आपके घर की बात नहीं हो रही है. But in an industrial process, they will put in molds and they will be put on a conveyor belt. It will take it to the oven where they will be baked. Once the cake is baked, you remove the mold and then you somehow eliminate the defects. अगर वो cream वाला cake है तो आसान है, because whatever is the base doesn't matter. ऊपर का slash करा, side से slash करा, ऊपर cream लगा दी, done. Simpler. But if it is not a cream cake, then those defects somehow need to be removed without changing the texture or overall feel of the cake. So those of you who have eaten Britannia cakes, जो आते हैं, you realize they are cut from two sides. एक तरफ आपको डार्क, दो तरफ आपको डार्क क्रस्ट दिखता है, दो तरफ नहीं दिखता है. That is also a corrective process for them, because in their cake making process, those two sides are the ones where cracks happen. Cracks don't happen on all sides. Have you noticed? Those who have baked cakes, cracks don't happen on all sides. They happen on only some sides. They उनके corrective process में उनको काट दिया. Correction करने की जरूरत नहीं. Eliminated the corrective process, trimmed the corrective process. And then decoration. So looking at the operations, so first thing is, when you are preparing the batter, first function is measurement. You have to measure every component in the right quantity. And then the second function is mixing. Both are useful functions. Mixing is a productive function. Measurement is obviously a supportive producing function, but mixing is a productive function. Because the final cake that you eat, you do not eat sugar separately and refined oil separately. You eat the cake. It has everything mixed. So mixing was a productive function here. Are you able to see this? See, the intent of going through these generic examples is that आपने जो अपने products या processes project से अंदर identify करें, you work out those. Okay? So then you go to filling. Filling ऐसे ही नहीं हो जाती है. Filling में you first make a very thin layer of oil ताकि cake ना चिपके. ठीक है? But that oil, that greasing, do you see that grease later? No. So it is a providing function. Providing function किस लिए डाला गया? ताकि आपको बाद में जब केक को निकालना हो, आप आसानी से निकाल सको. Are you with me? Useful? Yes, very useful. Then you pour the batter into it. And because you have poured the batter into that particular mold, finally that is the shape it takes. Therefore, this is a productive function. Again, useful. यहाँ तक we are in sync? Clear? Then transport. Move the cake mold towards the oven via conveyor belt. Yes, useful. Clearly transport function. And happening normally. So अभी तक हमने जितने भी देखे सबका normal हो रहा था. कोई defect या कोई गड़बड़ की बात नहीं देखी हमने. Then baking. First, measure the temperature in the oven. So measurement function. To continuously keep on measuring it ताकि एक same level तक रहे. Heat the oven. Heat the cake in the oven. Then again, एक और measurement यहाँ पे जो लिखा नहीं है वो है time for which it has to be in the oven. That also needs to be measured. After that time, you open and bring it out. Then removing, separate the cake from the mold. Useful function, but a transport function. Because what have you done? You moved something from one place to another. Mold के अंदर था, mold से बाहर निकाल के रख दिया. It is not a supporting function. It is not a corrective function. It is not a measurement function. It is not a productive function. Supporting function, a transport function. Okay? Then slice out the uneven surface of the cake. Useful, but a corrective process. And decoration, garnishing of the cake, again useful and productive now. So that is what is visible to the consumer, someone who is relishing the cake. Are you with me? So now, if we start to put, अब देखो हमारा इस केस में we said productivity is one thing that we want to improve. So very naturally, my metric of cost is time. I'm not talking about cost of ingredients now. I'm not talking about any other cost or cost of equipment or anything. For me, in this particular exercise, the x-axis cost comes to be time. Now, whatever your problems are, in those problems, you will have to identify what is the MPV, what is the cost. So आप हमेशा ये पाओगे, and we have repeated many times earlier also, that function models, flow analysis, trimming models, everything, same product के लिए it is always contextual. This course is a part of entrepreneurship minor. So you will realize that same idea, exactly same idea, two people are doing, outcomes can be very, very different. Why? Because their way, their context is different. They are trimming different things. They are uh, emphasizing different things based on what their customer segments could be, based on what they perceive as their value addition, what they perceive as their differentiating factor. Are you with me on this? So over here, the x-axis is that of time. And now in terms of time, baking is the costliest process, but it is also a productive process. Now, those of you who have really baked cakes, you also realize that उस केक को वहां से रिमूव करना ये आसान काम नहीं होता, बहुत केयरफुली करना होता है. आपने हल्का सा जल्दी मचाया, पूरा केक वेस्ट. ये तीनों ऐसे देख रहे हैं, अच्छा ऐसा होता है, हमें तो पता नहीं था, हम तो बस हड़प कर जाते हैं. But yeah, so removing is also a costly process put there. Preparation, decoration, filling, transporting, not so costly processes, but functionality. रियलाइज करो, अगर आपने केक का बैटर सही नहीं प्रिपेयर करा, बाकी सब कुछ अच्छा हो, इट विल नॉट टेस्ट गुड, अगेन वेस्टेड. सो फंक्शनैलिटी के टर्म्स में प्रिपेयरिंग द बैटर, वेरी हाई फंक्शनैलिटी, लो कॉस्ट, बट वेरी हाई फंक्शनैलिटी. ओके, देन डेकोरेशन थोड़ा बहुत ऊंच नीच होगा भी तो भी यू कैन स्टिल डू समथिंग अबाउट इट, नॉट वेरी हाई फंक्शनैलिटी, क्योंकि टेस्ट डेकोरेशन से नहीं आता, टेस्ट बैटर से आता है. सो फिलिंग, ट्रांसपोर्टिंग फंक्शंस हैं, बट functional value is low. So which one would you want to trim? The removing. Somehow you want to trim the removing part. You want to make the removing part. So when you say we want to trim the removing part, can you remove the operation of removing? No. Removing operation has to happen. But somehow you know that this has low functionality. If I can move it here, it would be acceptable to me. So आपका एक problem statement आ गया. How can I design a mold in such a way, in a way, that the process of removing is simple. It doesn't take that long. If you do that, do you realize productivity will go up? Maybe not to the level that you want, but otherwise you are completely up. मैं बोल रहा हूँ केक बेकिंग प्रोसेस की प्रोडक्टिविटी इंप्रूव करो, यू आर लाइक कहाँ फोकस करूं, बैटर जल्दी बना दूं, बैटर की मशीन बनाऊं क्या? Should I make batter machine or should I make a machine for transporting it? Should I increase the speed of my conveyor belt? But you realize they're already low cost. Only when you did a flow analysis and mapped your functions here, you say that, okay, oh, this is where it takes time. Let me do something to the mold. Now, that doesn't mean you will not do anything here. You may want to do some things here also. But if they're already low cost, how much can you save from there? Are you able to see this? So this will help you identify the cheapest problem which has the best, highest impact. Then somehow can you trim the baking part also? So trimming may. So the supportive function, heat the cake in the oven, probably because baking was high up there, can I do something about it? And it has very high functional significance. And we say that an operation with a supporting function can be trimmed if the operation requiring the supporting function is trimmed. One. Or the supporting function is changed, supporting operation is changed so that it does not require the support now. Or the supported operation performs the supporting function by itself. Or it is transferred to the preceding or the subsequent step. This is the hierarchy in which we will evaluate. And we want to see, can I move this supporting function of baking to one step earlier or one step later? Because heat to karna hi hai. One step earlier or one step later. And you will notice that you may have already seen these kind of machines. कहाँ देखे हैं आपने ये machines? पिज्जा स्टोर्स. खाली पिज्जा स्टोर्स में नहीं, आप किसी उसमें जाते हैं, बेकरी में जाते हैं, वहां पे भी आपको दिखेंगी. आप कहीं पे शादी में कहीं जा रहे हैं, वहां पे जो पिज्जा मिलते हैं तो वो भी इसी तरह के मशीन में मिलते हैं कि एक तरफ से डाला और दूसरी तरफ से लोग खाए जा रहे हैं. ठीक है. सो व्हाट हैज हैपेंड, द ट्रांसपोर्ट ऑफ दैट केक फ्रॉम kitchen side to the shop side is happening while the baking is also happening. Are you able to see this? So, cost बहुत ज्यादा कम नहीं हुई, but हुई. आपने दो functions को merge कर, दो operations को merge कर दिया. Coming to the next trimming problem, जो हमने कहा था कि that was again a very high cost. See, first one was a productive function. It was very, very important. We cannot really do much about it. तो हम जो कर पाए हमने करा. But second one is a supporting function, is a providing function, transport. I'm removing the cake from the mold. It is just a transport function. Very necessary. How do I trim that? Operation with a transport function can be trimmed if the object of the analyzed function is eliminated from the system. This won't work for us. Cake to we are producing. So cake to eliminate nahi kar sakte. Then the components between which the object of an analyzed function moves are eliminated from the system. Now, can we remove the mold? Can we eliminate the mold? No. The mold bhi rahega. This one also cannot be applied. The subsequent operations are changed in such a way that the necessity to perform the analyzed function is eliminated. Or the analyzed function is transferred to the preceding or subsequent operation. Again, we want to see, can I do something like that? Where the transport removal is transferred or is taken to the preceding or the later step. And while the cake is cooling, if I can remove the, so अभी क्या होता है, केक कूल होता है, उसके बाद आप उसके मोल्ड को रिमूव करते हो. What we are saying is, while the cake is cooling, can I remove the mold? Now, if while the cake is cooling, bake हो गया, cool हो रहा है, अगर मैंने उस समय रेगुलर मोल्ड है उसको हटाया तो क्या होगा? It will get, उससे साथ चिपकेगा या it would get deformed. So now, if you say that, okay, I have to have a mold which can be removed while the cake is hot. Why did this problem come? Or this problem statement, where did this problem statement come from? Because I said that I want to trim the removal process as a separate process. I want to use the trimming some other time to do the removal. तो अब रिमूवल के बाद इसके बाद का स्टेप तो डेकोरेशन है, उसके बाद तो उसके साथ तो मैं कर नहीं सकता. द ओनली वे इज preceding step, which is cooling of the cake. And for that, now you may have also seen kinds of molds where while it is still cooling, you may remove the bottom plate. You have this latch, just need to open the latch. So see, जब आपको केक रिमूव करने की बात आपको माइंड में आती है तो आपको लगता है अच्छा मेरे को उस बाउल में से वो निकाल के कहीं रखना पड़ेगा. Am I right? And that is where you want it to be cold enough ताकि it doesn't get deformed. As soon as I have this latch kind of a mold, I'm not lifting it, I'm not doing anything to the cake. So the probability of deformation is eliminated. And all I need to do is simply open this and this comes out. Are you able to see this? So we have in this entire flow analysis improved the productivity by these steps. In terms of the steps related to what do you say, cracks appearing, we have not discussed that solution yet over here. But we focus on the productivity. अगर हमें cracks के लिए करना होगा, तो what will you do? Think about what we did in the RBM. वहां पे भी defects आ रहे थे. हमें defects को eliminate करना था, corrective action को eliminate करना था. What did we do there? क्या करा था हमने तब? Okay, he's saying कि प्रोडक्टिविटी इनहांस और डिफेक्टिविटी रिड्यूस करने के लिए आप एक केक को चार मतलब इतना बड़ा बनाओ कंटेनर कि चार केक्स एक साथ बन रहे हैं. देखो अभी हम सॉल्यूशंस की तरफ भाग जा रहे हैं. मैं सॉल्यूशन पे नहीं चाह रहा हूं. मैं कह रहा हूं कि एज अ प्रोसेस व्हाट वुड यू डू? What did we use as a process of eliminating productivity bottlenecks? हमने एक टेबल बनाया, एक ग्राफ बनाया जिसका एक्स एक्सिस था कॉस्ट और वाई एक्सिस था फंक्शनैलिटी. और हमने सारे फंक्शंस को उस पर मैप करा. अब हम कह रहे हैं कि हमारे को इस करेक्टिव डिफेक्ट्स वाली चीज को हटाना है. First thing we need to do is identify what is causing these defects. In which functions the impact or the cause of defects is getting introduced. RBM process वाले जो exercise था उसमें हमने क्या देखा था? It happens during cooling. Why? Because if in the cooling phase we give or the cooling happens very slowly, then the crystallization starts to happen. It is those white crystals that give that white tint on the bottle. And then, since we analyzed the right function, we said, okay, cooling was the function. Then, cooling function की effectiveness को कैसे improve करें was the problem statement. The problem statement was not कि वो whiteness को हटाना है. The problem statement was how do I make that cooling function more effective? So abhi we need to look at why does this defect come? बैटर खराब हो सकता है, बैटर के अंदर कुछ हो सकता है. He quickly jumped to the solution also. Solution भी ये कर देते हैं. No. We're not looking at the solutions yet. We're looking at the process. The first thing that we need to do is identify what is causing these cracks. Can I eliminate the cracks in the first place. Then we're not even worried about, okay, agar maine height of my container बढ़ा दिया, तो the baking time will also increase because the heat has to go into a bigger thing now. So see, there will be other challenges that will come with that kind of a solution. So don't jump to a solution. Look at the process first. So what part of the overall baking process results in those cracks? Preparation part, okay, there could be an issue there. Heating part, the temperature is a little high or the cooling is done in a particular way, the cracks will appear. And here what you need to do, really need to look at, जैसे वहां पे हमने क्या करा था, we changed the mold in such a way that the coolant would pass not linearly but in a curved route. Similarly, you may want to now redesign your baking machine to say that, okay, टॉप पे सबसे ज्यादा क्रैक्स आने का डर रहता है, टॉप पे हीटिंग इस तरह से होगी. I will also blow air. I will also do something else so that my cracks do not even come. Are you with me? One very interesting method of eliminating a corrective step is to make defect a feature. फॉर एग्जाम्पल, फर्स्ट उसमें आपको क्या करना पड़ता है, आपको डिफेक्ट की इंटेंसिटी कम करनी पड़ती है, पहली चीज. तो यू हैव टू डू समथिंग ऑन एट वन एंड, एंड देन यू कुड से दैट जहां जहां पे भी मेरा क्रैक आएगा, वहां वहां पे आई विल फिल जैम और चॉकलेट, एंड दिस इज व्हाट माय यूजर विल सी. सो डिफेक्ट which was earlier a eyesore, now you have converted into a decoration step. आपने उसको डेकोरेशन का पार्ट बना दिया. You have trimmed the correction step then. Are you able to see this? वही, सो आपको पहले के प्रोसेसेस में भी इंप्रूवमेंट करना पड़ेगा, बट कभी भी डिफेक्ट को ऐसे मत सोचो कि मेरे को पूरा एलिमिनेट करना है. ऑल्सो always evaluate the defect in a way, can I convert it into a feature of my product? You know about this Japanese technique या कह लो या practice, जहाँ पे if a crockery, a cup or a something falls and breaks, they put the pieces together and they weld it with something like gold. And such crockery is very, very highly cherished. Not because of the gold in it, by the way. It is cherished because it reinforces to people that it's okay to make a mistake. It's okay to fail. We can still make something beautiful out of those failures. That is why in Japanese culture, such crockery, if you gift it to someone, they really regard it very highly. That you trust them with their failures also. Are you able to see this? So can you make the defect a feature is something that you can think about at all times, whether it is a software thing or कहीं भी. For example, errors आ रहे हैं, random errors आ रहे हैं. Can you make that as a feature for random number generation? So in hardware design, pseudo random number generation or random number generation is a very important feature, so that no one can, kind of the security feature, so that no one can know what is stored inside you in the memory or wherever. जो आपकी encryption decryption keys हैं, उनको generate करने के लिए this random number generators are used. So unclonable functions, puffs, are to be designed. Now, there are these random variations which we are talking about where things go bad. You have to handle them, manage them. Now, can you use them as a feature? That can be a thought that should always, हो सकता है वो feature आज use now, but at least आपने सोचा. That is what is important. Is it okay? So this is about flows and trimming of flows. Now, we can do a small exercise. I want you to again sit as teams. अपना जो project teams हैं आप उसकी तरह बैठे, and this will be a group exercise that I would want you to do. This exercise is called 9 screens. And this exercise is very, very useful to enhance the value of your offering, value of your product. What we will do is we will try to look at, so what we will do is we will make a kind of a matrix of boxes. So 9 screens, this 9 screens matlab 9 boxes hone hain. And in the center is your system. Okay? At the bottom is your subsystem. On the top is your super system. On the left is the previous version of your system. या पहले कैसे होता था वो काम. And on the right is the future version of your system. Okay? So what you need to do is, what you're doing is you're transporting yourself in terms of time and in terms of abstraction. Are you getting it? For example, at a system level, you may talk about a helmet. I don't know, whichever team was working on whatever products, you would say, okay, this is a helmet. Okay. So जब आप subsystem पे जाओगे, so you're talking about what is this helmet made of? Oh, पहले it was made of plastic, today it is made of this, in the future it will be made of this. So what this exercise will do is, जो भी आप अभी काम कर रहे हो, ये उसके अंदर नई प्रॉब्लम्स निकालेगी या आपको बता देगी कि देखो जो तुम उस करेक्टिव एक्शन की बात कर रहे हो ना, या तो जो तुम उस हार्मफुल फंक्शन को एलिमिनेट करने की बात कर रहे हो, that harmful function may become a feature later. Or this harmful function is coming because it was a feature earlier. Now, आज के सिस्टम में उसकी जरूरत नहीं है और कल के सिस्टम में भी उसकी जरूरत नहीं है. Remove the object of this function altogether. Are you able to see this? So this again is a problem identification technique, but now guides you differently along the time and system abstraction hierarchy. Because otherwise, how will you say I will eliminate a function altogether? You have no other way. 9 screen helps you do that. To imagine what is the future of your system and what is the super system. How will the super system evolve? How will the subsystem evolve? New materials may come. Super system may evolve that okay, अब तो self-driving cars हैं, कोई ड्राइवर सीट पे बैठा ही नहीं है, या आपका जो एयर बैग्स हैं स्टीयरिंग व्हील से तो आने ही नहीं. एयर बैग्स तो अब कार की बॉडी से आने हैं बिकॉज सेल्फ ड्राइविंग कार लेके जा रही है. आई डोंट नो, व्हाट आई एम सेइंग इज दैट आप जो प्रॉब्लम आज फेस कर रहे हो सकता है वो आगे जाके एग्जिस्ट ही ना करती हो, by the virtue of the evolution of the super system. So can you bring that feature now itself so that you can enable the super system happen earlier? And you will find that solutions that enable a future super system or a future system, there is not much crowding there. Very few people are thinking about the future. Most people are struggling with the problems of today. They are filing patents only for what they are able to see today. But through this exercise, you will be able to patent those ideas which are valuable in the future. And the field is also not crowded yet, because others have not even thought about it. Is it okay? So, yes. So again, see, this is one thing. Trimming से हमें लगता है कि हम solutions पे आ गए because I am showing the solutions also simultaneously. But in reality, how did I arrive at that uh, removable mold? I did not take you through the steps. Did I? Solution finding मैंने अभी आपके साथ टच नहीं करा है. मैंने बस आपको एक नई प्रॉब्लम दिखाई. मैंने कहा देखो इसका एक सिंपल सॉल्यूशन है. It was not obvious for you to arrive at that answer, was it? So for that, Abhi, you're still considering it to be black magic. Look, when we come to solution finding methods, we'll unravel the mechanics of that so that it doesn't appear like black magic to you. But how did I identify the problem? Is that part very clear? So it is a problem identification technique. I've shown you a solution, but don't get confused that trimming is a solution finding technique. No. It is a problem identification technique only. We have reformulated the problems so that we are now working on simpler ones. That is the problem. How can I, for example, remove the mold while decoration, while cooling? So that was the problem जिसका solution magically मैंने दिखाया कि ऐसा mold बना देंगे. कहाँ से आया वो आपको नहीं पता अभी. But there is a method to arrive at such solutions. We'll come to those methods also. Maybe not in the next class, but after the midterms, we will look at solution finding things. But until then, we are looking at problem identification things. So अगर अभी आपके midterm में सवाल आएगा, so I will not be asking you a solution to a problem. I will be asking you to frame 10 different problems for example, this particular system. Are you getting it? So अभी मैंने पढ़ाया ही नहीं आपको कि solution कैसे find करना है, तो how can I burden you with that? But as you simplify the problems, come up with simpler problems, you might also come up with some solutions. That's fine. But I have not yet taken you through the formal mechanism of finding solutions. So solution finding is a different set of tools that we will use. Abhi tak, even in 9 screens, this is a problem finding tool. Okay? So we will do another problem finding tool today itself. So please quickly form up अपने teams की तरह से बैठो and start to work on the 9 screens. Any question about 9 screen method? Is the method clear to you? You have to look at how did the system appear earlier, what was the system earlier, what is the new system. You have to look at what was the super system, what is the subsystem, what was the earlier super system, what is the new super system, and so on. Okay? It requires a brainstorm, so I want you to work as teams. We have kitna time? 15 minutes, 1-5. Okay? We have 15 minutes, 9 boxes to fill, 15 minutes should be sufficient. Try to make it within 15 minutes. IMC is practically available today. It's today's system. See, आपके सुपर सिस्टम में जैसे पहले जो कैलकुलेशंस होती थी, दे वर लीनियर, सीक्वेंशियल, तो वन न्यूमन वाज वर्किंग फाइन. आज एआई बेस्ड एप्लीकेशंस हैं, कल क्या होंगी? आज एआई एप्लीकेशंस हैं, कल क्या होंगी वो सोचना. उसके लिए क्या आर्किटेक्चर होना चाहिए वो सोचना है. Are you getting it? You may want to differentiate digital IMC, analog IMC. That also you may want to do. So, ये क्या है? Sound output. देखो देखो, एलिमिनेशन से सबसे पहले आपको कॉस्टिंग देखना है. What is the kind of battery that those LEDs consume? What is the kind of battery that you need? तो आपके लिए cost metric will be battery. Don't jump into कि हाँ, okay, this appears to be wasteful, but can you make it a feature? So same LEDs, can you make it a DJ speaker? नहीं चलेगा बैटरी से. आते हैं आजकल मार्केट में. But it is an additional feature ना, यूजर को दिख रहा है. It's like तुम फेरारी के अंदर से कहो कि मैं अब उसकी शेप चेंज कर दूंगा ताकि सस्ती हो जाए. बाइक के अंदर से तुमने गैस टैंक हटा दिया, लूना बना दिया उसको. अब लोग नहीं खरीदेंगे ना कुछ. यूजर इंटरफेस या यूजर को इतना हल्का मत लो. Make that matrix. तो आपको ये देखना है कि कैन आई हैव टू स्पीकर्स मर्ज्ड इनटू वन. सो विल टॉक सॉल्यूशंस. देखो सॉल्यूशंस से मत आओ, प्रॉब्लम्स आइडेंटिफाई करो. सॉल्यूशंस के मेथड्स हैं वो हम अगली क्लास में या उससे अगली क्लास में शुरू करेंगे. एंड अभी प्रॉब्लम्स को आइडेंटिफाई करो, जंप मत करो. अभी मैं आइंस्टीन का भी जो क्वेश्चन दिया है दैट इज अबाउट आइडेंटिफाइंग प्रॉब्लम्स, नॉट सॉल्यूशंस. ठीक है. सी हमारे को ना, आई नो देयर इज अ अर्ज to quickly jump at a solution and feel gratified. Don't do that. Innovation is a very disciplined process. Otherwise, you will come with substandard innovations. Exactly. वो substandard ही quick fixes ही patchwork ही सारे लोग कर रहे हैं, तभी प्रॉब्लम हो रहा है. Elegant engineers have to control the search. Okay? Don't jump at solutions yet. Solution finding के methods हम करेंगे. आपका सिस्टम है स्मार्ट पॉट. Okay. I don't know. It could be it is in the home, inside the home. It could be that it is in my balcony. That could be the super system. वहाँ पे balcony में सारी चीजें हैं. It's up to you. What do you want to? So मैं आपको component analysis करने को नहीं कह रहा हूँ. मैंने यहाँ पे खाली लिखा है what is the current super system looking like? What are the requirements of that super system? Because आपके सारे features उस super system से associated है. What will be the requirements of a future super system? Major pollution होगा, light कम आएगी, धुआं होगा. अगर हम यही rate पे चलते रहे, if we go a different rate, something else could be the future super system. Then a different product would make sense. Current system क्या है? तो सेंटर में वो डालो. प्रीवियस सिस्टम क्या था? आज आप ट्रक में ले जाते हो, पहले आप बैलगाड़ी में ले जाते थे। फ्यूचर में कैसे लेके जाओगे? आई डोंट नो, वो आपको ब्रेनस्टॉर्म करना है। एवरीथिंग कैन बी पार्ट ऑफ इट। सुपर सिस्टम को आप ऐसा भी देखो कि पहले any farm size, human was a part of that super system, any farm size. Today, आपका जो ये system है, this works for big farms only. These weeding machines work only on big farms. Small farms के लिए they are not there. So आपका super system अभी is big farms. Future में you may say that even small farms, I would want to use. So आपकी जो problem definition है, जिस context में आप operate करना चाह रहे हो, you can use that thing here. We are not doing a component analysis. आप जो यहाँ लिख रहे हो, this is human powered, this is electricity powered. यहाँ पे अगर आप power, but that is a input source. Input, अगर आप input लिखो, यहाँ पे क्या input था? बंदा जो देख रहा है। आज क्या input है? Again, there is a camera and a person is controlling. कल को क्या होगा? रोबोट अपने आप कंट्रोल करेगा। तो देन आप जिस भी लेवल पे आप ऑपरेट करना चाहते हो, उस चीज को लिखो आप। अगर आप यहाँ पे ह्यूमन कह रहे हो कि ह्यूमन पावर्ड है, यहाँ पे इलेक्ट्रिसिटी पावर्ड है, तो यहाँ पे आप सोलर लिखोगे। ये नहीं होगा, आप मिक्स नहीं कर सकते कि हाँ मैं इधर तो मैं टेक्नोलॉजी की बात कर रहा हूँ, वहां पे मैं यूजर एक्सपीरियंस की बात करना शुरू कर दूं। व्हाट आपको दो चीजें लिखनी है, आप दो चीजें लिखो। तीन चीजें लिखनी है, तीन चीजें लिखो। बट जो भी आपने प्रेजेंट के लिए लिखा, वही पास्ट और वही फ्यूचर। जो भी आपके एमपीवीज है, आइडेंटिफाई दोस एमपीवीज एंड उनके हिसाब से सुपर सिस्टम की पास्ट और प्रेजेंट और फ्यूचर को एन्यूमरेट करो। यू गेटिंग इट? डोंट मिक्स द एमपीवीज। सेम पैरामीटर पहले क्या था, आगे क्या है, नहीं तो यू विल गेट कंफ्यूज्ड। तुम बताओगे? गूगल करो, ढूंढो। यूज कर रहे हो अभी, चेक करो। तुमने मेरे को विकिपीडिया समझा हुआ है?
high speed. So उसमें but capacity needs more area. So our future system is without capacity to burn high speed area.
Why don't you say there could be a future system where there is no sense amplifier? I'm just challenging you. I'm not saying this is wrong. This is also fine. Proceed. But I'm just challenging you. थोड़ा सा मजाक तो मुझे करना नहीं। Yes, sir. But why are you not thinking big? That is what my question is. You have a very powerful tool at your hand. The bigger you think, the better solutions you will come up with. I'm telling you this. Don't fritter away this opportunity in terms of safety कि सर कैसे करेंगे? Ideas आने की बात है ना? क्या करेंगे तो देखेंगे। तो सोचो क्या करना होगा सुपर सिस्टम में। सोचो आज मेमोरीज कैसे बनती हैं, कल कैसे बनेंगी। आज मेरे को संसार चाहिए उनकी बिट लाइन्स इतनी बड़ी हैं, क्या मेरे को इतनी ही बड़ी बिट लाइन्स बाद में भी चाहिए? I don't know. Depending on application, they may be needed, they may not be needed. So you would say, I'm not making a generic solution. I'm working towards that particular application जो आज exist भी नहीं करती, या आज खाली niche market में exist करती है, but बाद में prevalent हो जाएगी. For example, GPUs थे. When the GPUs first came, they had some specific need for memories. Some people worked on it. NVIDIA really worked very hard on enabling such memories. Today, NVIDIA is at the top because they saw there is a need in a future super system. and they change the memory for that. You also think in those terms. Okay, this is an application that has come in. I already see this happening. So again, do you realize that you will need to know the system very well to be able to apply TRIZ? TRIZ is not a tool for, what do you say, hobbyists. This is a tool for serious people, experts. But in this process, you will become an expert. सबसे पहले ये भरना होता है. Then we go पहले क्या था, आगे क्या था. Then we also look at super system. आज क्या है, पहले क्या था, आगे क्या था. When you talk of either super system or subsystem, you would think of it in terms of your MPVs or parameters of value. Because MPVs पहले क्या थे, आज क्या है. How have they evolved? Was this MPV even there earlier? No, it was not there. So irrelevant. Now it is. In the future, it will again become irrelevant. So should I innovate on this MPV axis? No, not needed. But it was a parameter of value. It was nothing earlier. It is a parameter of value today. Tomorrow it may become an MPV. I better innovate on it. Are you getting it? It's a very powerful tool. Very, very powerful tool. It makes you ready for the future. ऐसे patents आते हैं इसमें से. इसमें से problems आएंगी which are directly, इसके solutions are readily patentable because the space is not crowded. As a researcher, this is very, very powerful. Not just as a researcher, even if you are, for example, wanting to be an entrepreneur. आज लोग इस चीज को value करते हैं. If you can anticipate how the market would move, you can already intercept that product before anyone else is thinking about it. You will disrupt the market. Latent MPVs. आज भी तक ये latent था, आगे जाके important हो जाने वाला. That was what Steve Jobs did.
Also, can you please explain the difference between super system and subsystem?
Super system is the context in which your system operates. It would include people around you. It would include the society. It would include customer expectations, blah, blah, blah. वहाँ पे वो, it could be, for example, the kind of applications. अभी जो वो मेमोरी के ऊपर, मेमोरी आर्किटेक्चर के ऊपर जो टीम कर रही है, उन्होंने कहा कि पहले लीनियर एप्लीकेशंस होती थी. आज एप्लीकेशंस हैं, इतना सारा, convolution neural networks के context में, there are so many accesses you need to make. You need to do multiply and addition so many times.
System.
It is in the context in which your system exists. Super system is the context in which your system exists. So what will be the new context? That is what we're talking about in this here. Subsystem is, how is your system made? What is your system made up of? Oh, it is made up of these kind of components. Oh, I was earlier consuming energy from coal. Today I am doing solar. Tomorrow I will do nuclear. Yeah, today I am doing nuclear. Tomorrow I will do wind. Depending on what product, what we are talking about. So that may become a subsystem. That for someone else, it may be a super system part also. आपके लिए, so आपका, depending on what your product is, what your application is, it will change. Even flows. आपका program पहले यहाँ run होता था, अब यहाँ run होता है, अब ऐसे run होगा. It will change. ठीक है? Okay. No. So आपने यहाँ पे दो चीजें लिखी हैं. मैनुअल स्टोरेज टैंक्स. वो आज क्या है, उसका आज स्टेटस क्या है. आपने यहाँ पे दो चीजें लिखी, तो दोनों चीजों का रिप्रेजेंटेशन यहाँ पे भी होना चाहिए और यहाँ भी होना चाहिए. ओके. Okay. Yes. Simple filter cartridge. दिस इज फाइन. अब आगे बताओ क्या हो. अब जो आप प्रोडक्ट बनाना चाह रहे हो, दैट कुड बी द फ्यूचर प्रोडक्ट. लिखा है ना आपने? मैंने लिखा था, मैंने पढ़ा अभी. तो फ्यूचर सिस्टम में वाटर, तो वाटर स्कार्सिटी बिल्ड अप हो रही है नहीं अभी, तभी तो आप आरओ यूज कर पा रहे हो. पहले लेस कंजम्पशन थी, टुडे हाई कंजम्पशन है. यहाँ पे आपको वाटर स्कार्सिटी है. वाटर स्कार्सिटी में नाउ वेस्टेज इज नाउ द की एमपीवी इज वेस्टेज ऑफ वाटर. फ्यूचर आरओ वेस्टेज इज जीरो, है ना? Yes. Track. सेल्फ क्लीनिंग करोगे ना आप. ठीक है, सिस्टम हैज अ रोबोट नाउ. ठीक है. अब नाउ यू थिंक कि अच्छा, जो भी आप सॉल्यूशंस देख रहे हो, which one of them solutions are valuable in the future also? Are you getting it? Yeah, it is also to guide which ones do you want to trim. Basically, जो हम value estimate करनी थी किसी feature की, it is to also point you towards that. But more importantly, it is to give you a problem. Oh, I'm already working on this. In the future, this thing will also be required. Can I already solve that problem now itself? So that the value of your solution increases. Instead of sequentially going there later, this process helps you leapfrog. It's a very, very powerful tool. Yes. Yes. कि भाई देखो अभी क्या है, अब ये प्रॉब्लम आ रही है बिकॉज मेरा सबसिस्टम में दिस मटेरियल इज यूज्ड, लेकिन कल को द मटेरियल विल एनीवेज चेंज, दिस प्रॉब्लम विल नॉट इवन कम, आई डोंट नीड टू सॉल्व इट. Let me rather work on bringing that future system into the world faster. Why solve a losing problem? You see, this will help you identify the right problem to solve, to work on. We don't say reuse of water, we say zero water wastage. Okay. तो सुपर सिस्टम में आपने वाटर स्कैर्स थिंग एंड द कंजम्पशन हैज टू बी रिड्यूस्ड. पर आप इसको पर कैपिटा कंजम्पशन की तरह कर सकते हो. पर कैपिटा कंजम्पशन वाज 5 liters. Per capita consumption is 20 liters. You want to take it back to 5 liters or 10 liters, something like that.
the subsystems. We have first identified that we can make our mobile frame better because that is what most of the wastage, and then we can add smart water molecule.
ठीक है, वो सब आपके फीचर्स हैं, वो तो आप बात. Is it okay? Can we move forward? You need more time? Kitna? 2 minutes? This is your project. You can't complete the project in the class, but 2 minutes. Can we quickly wind up in 2 minutes? Mhm. देखो क्या हुआ है ना, आपने करंट सिस्टम में अभी टेक्नोलॉजी लिखा, फ्यूचर में आप लिख रहे हो सेल्फ डिसीजन मेकिंग. दिस इज नॉट अ टेक्नोलॉजी दैट यू टॉकिंग अबाउट. आपको कुछ विजन का नहीं चाहिए होगा, बस एआई से काम चल जाएगा आपका. उस टेक्नोलॉजी को लिखो ना. You cannot change कि भाई इसमें कुछ और उसमें कुछ. We're talking about the same parameter. How is it evolving from past to today to the future? Don't mix up MPVs. आप इधर 3 चीजों पे इंप्रूव करना चाहते हो तो 3 चीजों को लिखो, बट तीनों का कॉरेस्पॉन्डिंग हर तरफ बताओ. Are you getting it? ये क्या है? Future could be screenless. I would use the wall as a screen or my table as a screen, something. तो क्वांटम कहाँ से आया? अब देखो, हाँ तो टेक्नोलॉजी ठीक है, तो आपने यहाँ कहा वैक्यूम ट्यूब बेस्ड टीवीज, यहाँ पे आपने कहा एलसीडी एलईडी बेस्ड मॉनिटर्स, तो यहाँ पे बताओ क्वांटम मेटा एलईडी बेस्ड क्या? समझ रहे हो कि आप जो भी चीज के बारे में लिख रहे हो, इट हैज टू बी कंसिस्टेंट अक्रॉस ऑल द 3 बॉक्सेस. ये नहीं कि आपने एक जगह पे यूजर एक्सपीरियंस की बात करी, दूसरी जगह पे सोशल एक्सपीरियंस की बात करी, तीसरी जगह पे किसी और चीज की बात करी, टेक्नोलॉजी की बात करने लग गए. नो. टेक्नोलॉजी की बात करें तो तीनों में टेक्नोलॉजी बताओ. जब यूजर एक्सपीरियंस की बात करो कि पहले का बताओ, आज का बताओ, कल का बताओ, तो आपकी तीनों चीजें हो सकती हैं. जरूरी नहीं है एक बॉक्स में एक ही चीज लिखें, आप 3 चीजें लिखो, बट तीनों चीजों को फिर पास्ट प्रेजेंट फ्यूचर, सब सिस्टम सुपर सिस्टम एंड प्रेजेंट सिस्टम, तीनों चीजें. A subsystem is, for example, you would say for memory, subsystem is the 60 memory cell. ठीक है? In the future, I will use RAM based memory cells. That is how the subsystem has evolved. Once you have an RAM based cell, would the same problems remain or new problems emerge? Do you know? आप suppose sense amplifier पे काम करें. The kind of sense amplifier you're working today, does it need to be the same solution that you're looking at today than what you need for RRAMs later? Can you already bring in the features of the future solution in your today's solution so that when you patent, it has a long life? It is not a losing battle. So subsystem is about what is making your system. Super system is the context in which your system operates. Are you getting it? And again, जो भी आप parameters of value या main parameter of value लिख रहे हो, उनको आपको सारे 9 ब्लॉक्स में उसके रिलेटेड चीज आपको लिखनी है. ये नहीं कि यहाँ पे आपने कुछ लिखा, वहां पे कुछ लिखा. But as user experience, then you talk about UI today, UI last year, UI next year. If 1 year is your frame of time. You're getting it? So let's come back. How was the exercise? What did you like? Did you get new insights, new ideas, new problems that you could work on? So still the same context, but new problems. So someone would want to share. Hmm.
स्पीकर को टारगेट करके पहले पे देख रहे थे तो मतलब पहले जो कंटेनर होता था जैसे स्पीकर का तो काइंड ऑफ वो
नहीं, मेरे को तुम्हारा 9 स्क्रीन नहीं चाहिए. मेरे को चाहिए कि what new problem did you identify? Did you find a place where you could now innovate, which you were not thinking before you entered into this exercise? So I want that problem statement. Okay. So you felt that the subsystem level, there could be a lot of innovation that could be possible. So depending on what kind of innovation is happening at the subsystem, the problem may not even exist in the future system. So you may decide not to work on the problem at all. Instead, enable the subsystem. Okay. What about others? What did others experience? Hmm. Okay, so you're saying that you have identified that your system, the technology that you use in your present system can be evolved. And that whatever now, suppose you're looking for a solution finding thing, you would want to keep that future technology also in mind when you're finding a solution. Another thing could be you may say, okay, the present technology is a losing battle. Now, depends on which context you're talking about. The present technology is a losing battle. If I find a solution in 2 years, tab tak to future technology aa chuki hogi. So the solution will be worthless. Instead, let me focus on finding a solution to the future problem so that when I hit the market, I'm at the right time. Are you getting it? Okay. What else? What did others see?
like in our system the MPV was wastage, so we have not identified any new problem. But one of the future subsystems we have identified is we can have a based water monitoring or smart water monitoring kind of thing. Can be like monitor water the quality stage.
So what they realized was that in the future there will be need for an electronic system inside the RO that they are working on. So while they are not material science engineers themselves and they do not have a solution for the technology part of the system, they know that the system will have another component. And they can now start to work towards that, building that component so that they can help that future become a reality faster. Enter into a market where probably no one else is working on it yet and giving them a leapfrog capability. Okay. What about others? Introduction of a completely new subsystem in the system. Okay. Okay. Good. What else?
In my system, there's AI managing both things. But now I feel that what if AI can also teach? That was a bigger.
So you've added more functionality, which you may want to keep a scope of now, or that is also just about the strategy of your product. So this method, 9 screens method, you will realize can help you not only arrive at new problem statements, but also build a strategy for your product. Completely आपके operations को नई markets open कर सकता है. It can be very, very useful in many, many different kinds of settings. Is that okay? Obviously, it can also help you leapfrog in terms of research, because that is the main intent for many of you over here. But even for those of you who are looking at it as an entrepreneurial activity or business activity, it can help you identify a better strategy, where whatever you do is valued more by the organization that you're working for. Is that okay? Now, I would want to take you back to this thing. We had discussed this thing. When did we discuss this chart?
MPVs have discussed that.
when we were talking about the main parameters of value analysis, we had said that these are the top level needs that consumers have, that users have. We had also looked at the examples of how the phone has evolved along these MPVs. We had taken all those things there. So अभी इसको वापस लाने का इसलिए importance है because now all of you may have different problems that you want to work on, different problems that you want to solve. And very soon, you will enter into a zone where you will have different solutions that you have to choose between. So we need to do an exercise called benchmarking so that we can identify the right problems, or we can set the boundaries around the problem so that we can do something meaningful in our projects, in our assignments. Not course assignments, not course projects. When you are in a job somewhere, when you are in a startup, whatever you are doing, every activity will be a project. आप उसको कोर्स प्रोजेक्ट की तरह मत सोचो. Every activity will be a project, and you as a leader has to decide what to choose to work on, focus on, and what to postpone for later. So we need to identify the right problems, and then later we can also use the same methods to identify the right solutions. What I want to bring to your attention is that we have already discussed this part of MPVs earlier. Now we will use that to benchmark different problems or find out which are most relevant problems to solve. Is that okay? So what you need to do is, you need to list down the MPVs. MPV1, MPV2, MPV3, and alternatives. For example, if I work on this problem, these MPVs get enhanced. If I work on that problem, those MPVs get enhanced. If I work on third problem, another kind of MPVs get enhanced. And then you can merge all of that and propose something and say that, okay, this is my proposal, that I will work on this problem and these kind of constraints so that I'm able to deliver a different output. And you can also arrive at what would be there in your, so इसी टेबल को आप यूज करके ये भी कह सकते हो कि आपका मिनिमम वायबल प्रोडक्ट क्या होगा. What is a minimum viable product?
A version of like it's like a model that has all the necessary functionalities that you need.
A minimum viable product is something which does the job. Maybe not to the level of effectiveness that you want to have in your final product, but it does give the user a taste of your offer. So in the morning, in the Mary class you were talking about, so sorry, अब इस room में मुझे पता है बहुत सारे लोग सुबह की class में भी थे, so I just want to connect the dots. It will become easier for them. But for others also, it is not something that I'm talking alien. You can understand it, and if you don't, you can just raise your hand and ask. So in the morning, when we were in the memory class, we were discussing about a business model या कोई भी जैसे we were talking about आप अगर अपने घर का चूना भी white wash भी कराने के लिए गए हो, तो you make a contract with the person there. You say that, okay, when you will whitewash the living room, I will give you this much. When you will whitewash the other two rooms, I will give you the remaining amount. In the beginning, I have given you some money. So what do? You do? You define some milestones. And once those milestones are getting completed, you give some money to the painter or whatever. Similarly, in every business, things are, milestones are set. So first milestone that people would set is a POC, show me a proof of concept. So in the class today, we were saying that companies would usually set a milestone, give me 100 working samples. Why? Because I want to do some testing on it. Maybe user testing, I want to develop my software around it. I may want to do so many things around it. So give me 100 working samples. Now, those working samples that you give, or to give the full functionality, may not be at the right level of performance, but they are working samples. That is what the user demanded. That is what we call as minimum viable product. On your minimum viable product, the user will be able to test their most important hypothesis, probably accept performance. Even for performance, they should be able to test what is the kind of improvement that their algorithm can bring about from baseline to using their algorithm. They know that this number will change, but at least they know that the algorithm works. The gain is not zero. Are you able to see this? So minimum viable product is that version of your product that you can actually launch into the market for early testing. It has all the features that are required, but may not be to the level of performance as you wanted them. So for example, over here, you said, I want to come up with a RO which has improvements across all the 4 MPVs. And यहाँ पे आपने कहा delight है. वहाँ पे भी आपने कहा delight है. But in the MVP, minimum viable product, you said, okay, I will not give delight in this just yet. But this is something which is very important for the user. I will achieve the same level of performance here. I could have put a yellow here somewhere. And I would have said that, okay, my proposal is a green smiley, but I will still just give it as a feature. In final product, it will be this. But in the version that I'm giving to you today, because this is something that you don't want to test, this is not your objective, I will just give it to you as a feature so that you can, these are the hooks, these are the place where you have to put the pins, this is the place where you have to store something or some configuration you need to do. This is not your MPV, so I'm just giving you something working so that you can go ahead with your development. Are you able to see this? So this benchmarking at the MPV level will help you identify which problems do you want to solve in which time frame to what level of performance. Is that okay? Any questions here? So MVP is clearly not is production ready, but not production worthy. MVP is a prototype, but it is a prototype which is sufficiently functional on the most important features that the user needs. Maybe it will not perform to the same level of performance, but it has all those features already available and functional. Okay. Anything else? So once you have this, there is also one more step that you can do. You can say that, okay, there are a few criteria which my solution should always meet. So अभी आप solution के लिए framework बना रहे हो, अपने problem को आप further strengthen कर रहे हो. Okay, but there are certain criteria which the solution should always meet. They are non-negotiable, and I cannot even prioritize amongst them. They have to be met. These are called absolute criteria. Okay, and there are desirables. These are nice to have. अभी भी जो आपने 9 streams में बहुत सारी चीजें लिखी, you will realize some of them are desirable, some of them are absolutes. So what do you do? To be able to analyze such a system, or multiple ideas or problem statements that you may have, first you do is, okay, which of those problem statements or which of those solutions meet all my MPV requirements? You see that amongst these, idea B, idea D, and idea E are either partial problems or partial solutions. It may not be worth pursuing them. It will increase your effort. So idea A, C, and F, you now take forward and discuss or review the parameters of value on them. Now on these parameters of value, you do something else. You say, I will add a weight. Because they are all parameters of value. But each parameter of value has a different weight. So you put a weight there. And then you see which ones of these ideas or which one of these problems will actually solve which of these PV improvements that you were targeting. Are you getting it? And then you may have a total score which will help you identify the final problem statement that you would want to solve. नहीं समझ में आया. So let me present it to you in terms of solutions, let us say. Problem statements की तरह से अगर अभी नहीं आया तो solutions की तरह करेंगे तो आ जाएगा, and then you can retract it to a problem statement level. अभी हमने solution finding exercise नहीं करी है, therefore I do not want to really talk about it in those terms, but we can still assume that for any problem statement that we have, our solution finding methods will result in 6 solutions, let us say, A, B, C, D, E, F. If my problem statement is clear, then in this benchmarking, I would have clear values of what are the MPVs that have to be met and clear values of parameters of value also, along with the weights. Are you with me? यहाँ तक clear है? Because I have defined my problem well, so this table is already ready. Now I ideated and I came up with 20 solutions. इस case में, let us say A, B, C, D, E, F. 6 solutions. I have 6 ideas. I now want to see which of these ideas should I take forward. See, आपने brainstorm method से बहुत सारे ideas निकाल लिए ना? But do you remember we said that TRIZ is about finding the golden nugget directly, not really doing a hit and trial? So which one is the most valuable of these ideas that you would want to implement? Are you able to see this? So that is where you first do a MPV analysis. Only those ideas that meet your absolute criteria have to be taken forward. Only ideas that meet all your absolute criteria have to be taken forward. And amongst those, because there could be more than one, amongst those, you will use the criteria of parameters of value, the desirable criteria. And then decide which one is it that you would want to implement or work on. Is the solution side part of it clear? Solutions को कैसे evaluate करना है clear है? मैं कह रहा हूं जो आपने इतनी सारी problem statements निकाली है ना, they are the solutions of your present exercise. आपका present thing was identify problems. And your MPVs could be, do I have the technical knowledge to solve this problem or not? Your MPVs could be the time it would take, like what is the present state of technology to be able to solve this problem? Your MPV could be the cost it would take to solve this problem. And then you see, okay, मेरा criteria था that it has to be solvable within 2 months by 3 people, because that is the size of my team. And I should be able to give a demo of the problem solution by the end of 2 months. These could be your MPVs. Now, whichever of the problems you think do not fit the criteria, those problems you don't work on. You say, okay, this problem statement is not what I'm looking at. See, finally, you know that you're trying to solve the big problem and arrive at a big solution. But which route you have to take, you have to still identify that, is it not? अभी तक तो मैं आपको problems के brainstorms करवा रहा हूं ना, through component analysis or function modeling and trimming. I led you into 10 different kinds of trimming problems which could solve the problem that you are wanting to solve. Through the flow analysis trimming, I again gave you a method to arrive at multiple trimming problems which you could solve to solve the problem that you are handling. Now, for some of the problems, you may be skilled. For some of the problems, you may not be skilled. You may not have the resources. So how do you identify which ones to solve? This benchmarking comes in handy there. Are you able to see this? So in the next class, we will do one more method of problem identification. And I would really want that आप अपनी teams के साथ काम करें और next class में we are actually able to see your real problem statements and what is evolved out of them. Like what is the problem statement that you would finally want to work towards solving. जिन पे आप फिर solution finding methods लगाओगे. Is that okay? So depending on how much we are able to do in the next class in terms of your review, we will see we may need a presentation in the first week after the midterm or we may not need a presentation अगर आपके सारे groups cover हो गए तो. Is that okay? चलिए. Any questions about it now? Is it clear? Anything else? Yeah, so for example, over here, idea A, that improves parameter PV2, PV3, PV4, and PV5. It does not do anything to PV1 and PV6. So those boxes are empty. Okay, so whichever PVs your idea can or the problem statement can solve, that you add. Is that okay? That you come out from user analysis or the system analysis. कि आपके लिए what is the most important thing or what is the most desirable thing? You have to know the system well. अभी मैं यही कह रहा था कि Triz is not a tool for hobbyists. जिनको hobby की तरह creativity सीखनी है, Triz is not a tool for them. Triz is a tool for people who really want to innovate and come up with inventive solutions. So you have to be an expert or be willing to be an expert because it will require a lot of study, a lot of discussions, a lot of brainstorm. Don't take Triz as a fun thing. Triz is fun. Okay, you will enjoy it. But it requires you to have the technical know-how to be able to ladder up and down. So you need to know the system very, very well. Okay? Shall all the best.